So lesson 2.8 is about the algebra of functions. Just operations on functions, composition of functions, things that you might have touched upon in an algebra class previous to this. But I'm going to assume you haven't, and so we can kind of break everything down, okay? So the four basic operations, addition, subtraction, multiplication, and division, are possible with functions. And basically all this is saying is that if we want to add two functions, we can add their individual values. If we want to subtract two functions, we can subtract their individual values, multiply individually, and divide individually. So it's nothing weird there. But what it is going to allow us to do is input into some things in a slightly different way than we have before. We're going to practice working on a variety of function inputs, and we'll see how it goes. Okay? So they have given us three functions, f, g, and h, and they've asked us to find a variety of things, so let's just dive right in and take a look at them. So if we look at problem number 1, our input value is -3. So use my parenthesis idea to help you. Wherever we see the x, don't write an x, write a -3. Watch your signs. So -3 squared is 9. Two negatives here make a positive. And then we get 19 for an answer. Simple as that, right? Watch the function you're using. So like 2, you'll notice that they have jumped to 4. And so that's going to be the square root of 8 minus 4, or the square root of 4, or 2. And then let's do g of 10. Let's do number 4 down here. That's going to be the square root of 8 minus 10, which is the square root of -2. Now, if they want it to be a real function with real values, this wouldn't exist on the real number line because technically there is an I. So, be careful if they did ask you to find graph it or something of that sort. G of 10 is not a solution, okay? Now, let's practice inputting into our f function and expression here. So they want us to plug in a plus 1. So first, let me just write it, and then I'll blow it up so you can see it a little bigger. So that's going to be a plus 1 squared minus 3 times a plus 1 plus 1. You see what I'm doing here? I'm putting where the x's were sitting. I'm taking them out, parentheses, a plus 1. Okay, so let's now practice simplification. So remember, that's going to be a plus 1 times a plus 1. Let's do that multiplication first. When you FOIL it, you're going to get a squared plus a plus 1. Now, if you know the shortcut method and you can get to that or something quicker, go for it. It doesn't matter to me. And then we're going to distribute the -3. We distribute the negative and the 3 to both. So that's going to be -3a minus 3 plus 1. Combine your like terms. That's as far as we can go. So we'd have a squared. A plus a minus 3 is minus a. 1 plus -3 plus 1 is -1. So you can't do much else when you see ones like that. Okay. Now, here's the first one, because those other ones we have done already, but let's take a look at number 5. It's the first notation that's a little funky. The way that we want to think about that, and I'll write it so you can still see the functions first, and then I'll blow it up a little bigger. You want to think about this as the f function with -8 plugged in minus the g function with -8 plugged in. That notation is just a shortcut. The mathematician, is going to try to write it as shortly as possible. So they didn't like writing this out, so they used this shortcut notation. But that's what it means. Okay? So now, let's plug -8 into our f function. We're going to get 64 plus 24 plus 1. Now, be careful of this next part. We are subtracting So use parentheses so you remember to subtract the g of -8 answer. Now, if we plug -8 into the g function, we get the square root of 16. And so we're going to get an answer there first. So it's going to become -4, and then we're going to do it. So 64 plus 24 plus 1 minus 4 is 85. Okay? Any questions about number 5? Now let's look at number 6. For number 6, it says g of h of 0. Now that's a shortcut for take the g function, plug in 0, and then multiply it by the h function when I plug in 0. So it just lets them write it shorter, but you're just plugging 0 into both functions and then multiplying. If I plug 0 into our g function, I get the square root of 8. If I plug 0 into the h function, I get 2. So the square root of 8, remember, is 4 times 2, which is 2 square root of 2. So the answer is 4 square root of 2. Now let's take a look at h of -1. If I plug -1 into my h function, I get 2 over 0. Just like number 4, where this is an undefined value on the real number line, this is an undefined value on any number line, unless you define it some sort of strange way, which mathematicians don't usually do. So if you end up with 0 denominator, hey, that value doesn't work. If you were to graph it, that value on your graph would either be an asymptote, like a blank spot in the graph, or there'd be a hole in the graph in that spot. Any questions about 1 through 7? Okay. Now, we have, we're going to take these functions, we're going to subtract 2 of them, divide 2 of them, and multiply 2 of them. And then we're going to talk about the domain. Okay? Now, the domains can be kind of funky, but let's just take them piece by piece. Okay, so first, r minus t. So remember, that's just the r function minus the t function. Put that t function in parentheses so you don't screw it up. Now let's look at what each individual function was. The r function is a parabola. Its domain is all real numbers. Nothing screws it up. The t function is a line. Lines, you can plug in any x's you want. What we're going to get here, let's distribute that negative. Let's rewrite it in nice simplified form. We get what's called a polynomial. We started out with 2 polynomials. If you add, subtract, or multiply them, you will always get more polynomials. And the domains of these are real numbers, from -infinity to +infinity. That's the interval they're looking for. What x values can I plug in without screwing it up? Well, you can plug in whatever the heck you want. Now the problems occur if your original functions were rational functions like s of x here, or if you try to divide them. Okay, so let's look at number 9. It's going to be r of x divided by t of x. Oh, I guess I just totally ignored that and sure didn't subtract it now, did I? I'm sorry. This should become a -1. Is that the 3 you were talking about that I totally ignored? Oh, good, good. Thank you for catching that for me. Okay, but again, all polynomials, nothing's going to screw that up. We can put in whatever we want. Now the problem what occurs is if our original function, if we try to divide them, okay? So this really just means r of t, those are x's, I'm sorry, r of x's divided by t of x's. So let's write them down. So it's just x squared plus 3 over x plus 4. Now you can't do anything. That's as far as you can go as far as simplification goes. If you could try to simplify, great. But remember how we had some equations where we had restricted values? Well, think of a domain kind of like that. What are the restricted values? What would make it not work? Well, take the denominator, x plus 4. Let's make that look like x plus 4. Set it equal to 0. Solve for x. That is your restricted value. Exactly, Adam. That x cannot equal negative 4. Now, that means we have to skip over negative 4. We can plug in any other value we want. There are no other restricted values. So our domain for this one, we need a formal mathematical way to write down, I can use every number but negative 4. So I can use from negative infinity just up to negative 4. I'm going to leap across it. I can use anything on the right side of negative 4 to infinity. And so that's how you show this means there's a gap there because we don't have a bracket on the negative 4. It means that we're going to include it, okay? Or we're going to skip it by using a parenthesis. So the bracket absent means everything is super, super close to it, but not really at that point, okay? Let's look at our last one on this section here, number 10. It says s times t. Well, that is just the s function times the t function. Now, multiplying two functions is not a problem, so that's 2 over x times x plus 4. Okay, so we still have this restricted value because just like our equations that gave us restricted values, rational functions give us restricted values. But let's write it a little nicer. This is going to be 2 times x plus 4 divided by x. Now you can't cancel that x out, unfortunately, because it's not a factor that can be divided out. So just leave it, okay? And you would think, okay, x cannot equal 0. And then just like we had to skip the negative 4 in number 9, let's skip the 0 in number 10. So we're going to go from negative infinity up to 0. We're going to skip it. We're going to go to the other side of it and keep going for every number, okay? So that just implies there that we have skipped the 0. The parenthesis means I get super, super close, and then I jump across because there's some kind of obstacle or problem there, okay? Any questions about 8, 9, or 10? Now, on our last test, we had talked about the slope between two points as an average rate of change. Well, one of the things that will be important for the average rate of change as you head toward calculus is something called the difference quotient. And the thing that you need to know is that right there is the difference quotient. And I'm going to show you how to simplify the difference quotient. I'm not super concerned that you know what the difference quotient is really telling you or understanding necessarily, you know, this picture over here or anything like that. What we need to know is just the simplification process, because if you head to calculus, that's what you're going to need to know, how to simplify it, okay? So let's say that we have, number 11, this function, 5x minus 2. And they asked us to find f of x plus h minus f of x over h, our difference function. The first piece that you always want to find if they ask you to find the difference quotient is this, f of x plus h. You'll notice that's kind of what they've asked you anyway for your first step. So first let's calculate f of x plus h. Now it's just an input like we've done in the past. Don't overthink it. Okay, so we're just going to take 5 replace the input of x with an x plus h. We're going to distribute. We're done. Can't do anything else. Now, here's why it's important to do that first. In the difference quotient, that comes in the first spot anyway. So, write the difference quotient to the side. And first thing you want to do on the top of your division bar is write out what you just found. Because you already took the time to simplify it. So do it kind of, it's separate, which is what they asked you kind of to do anyway. And then let's plop it in its correct location. So we're going to put the 5x plus 5h minus 2. And then comes a minus symbol. And then the next thing is f of x. Well, they told you what f of x is. Don't overthink that. Just put it in parentheses. F of x is 5x minus 2. And then you always, as part of the difference quotient, put it over h. Now here's the kicker. All of these will simplify so that the h will cancel out as one of your last steps. That's kind of how you know you did it right. There's like a built-in check into the system. If the h can't cancel out as one of your last steps, you did something weird. Okay. So the next thing I want to do is distribute the negative. I get 5x plus 5h minus 2 minus 5x plus 2 all over h. Now, here's where you can kind of tell you're on the right track. Everything that doesn't contain an h should cancel. So look, 5x has a negative 5x. Canceled, yay. Negative 2, positive 2. Canceled, yay. What's left? 5h, which is divisible by h. The answer is 5. Okay? So the difference quotient is something that you will explore more in a calculus class. Now, just make sure you understand how to set it up and reduce it down. Let's do one more. Okay, let's do it again. Set up f of x plus h. So that's going to be x plus h squared minus 3 times x plus h plus 8. All I did was input x plus h. Now let's make it as pretty as we possibly can so we have less to write later. So this is going to be x squared plus xh plus xh plus h squared minus 3x minus 3h plus 8. Now, combine as much as you possibly can. And usually there's not a lot, unfortunately. We can just bring these two together. So we get x squared plus 2xh plus h squared minus 3x minus 3h plus 8. Okay. Now let's write our difference quotient. So that's done. So we're going to write f of x plus h minus f of x all over h. Okay, so you already found it, f of x plus h. Now it's a big, long, disgusting thing. Just write it out. Then put your minus symbol, and in a parenthesis, write down your f of x. Here's our f of x. Write it down. And then it goes all over h. Does everybody see the initial setup of our difference quotient? Good. Okay. Now, let's practice the last simplification. And we're almost done, guys, I promise. And so we get x squared plus 2xh plus h squared minus 3x. I'll tell you, and especially you already know me enough to know I sometimes can't read my own writing. I write things down wrong. It's easy to get lost in this process because there's so much usually to write down. So just try to be really careful. That being said, let's distribute the negative to all of those. We get negative x squared plus 3x minus 8 all of h. Now, let's look for things that are opposites that should cancel. Well, x squared and negative x squared canceled, yay. Negative 3x and positive 3x canceled, yay. Positive 8, negative 8 cancel, yay. So what's left? 2xh plus h squared minus 3h all divided by h. They should all contain an h because we should be able to divide off the h. That's how you can tell your algebra was right. Well, if we divide an h off of every one of them, we get 2x plus h minus 3. Any questions there? Okay, so there are some difference quotients. Just practice them. You know, they take some time, but they're not too bad. The last thing I think we're going to talk about, is composition of functions. Now, please, please, please be careful. If you see this little open symbol there, that is not a multiplication dot. It is a composition dot, which means something different, okay? What it means is f composed with g is that we put the entire g function becomes an input into our f function. With these, the order matters. F of g of x is usually not going to give you the same answer as g of f of x. The order is the inside one, the one to the right of the little composition symbol, is the thing that's going into the outermost one, or the one that's to the left. Okay, so let's do 13. You'll notice they've asked us both directions. Find f of g of x and g of f of x. Let's start with f of g of x. We're going to take the f function, and its input is g of x. This goes into there. So what I like to do is write the notation we're used to. What is g of x? Well, g of x is 5x plus 4. Put it right here. If I could write it nicely. Put it right there. Now we know what to do with that. It is our input. So in our f function, we're going to take out all of the x's, and we're going to put in 5x plus 4. Then do what you can do to it. Yeah, there might not be a lot you can do with it, but let's do it. So if we simplify this, and I'm running out of room, so I'm going to try to write all the steps out right now. You're going to get 25x squared plus 40x plus 16 minus 15x minus 12 plus 1 for a final answer of 25x squared plus 25x plus 5. Okay, so that is f of g. Now, let's take a look at g of f. Now, g of f is taking the g function and plugging f of x inside. Okay, so we're going to take the g function this time, and we're going to plug f of x into it. So why not do what we're familiar with? Let's take the f of x function and just write it where it goes. So this is going to be g of x squared minus 3x plus 1. Now we know exactly what we're inputting now into our g function. So it's going to be 5 times the input plus 4. Well, what's our input? Our input is x squared minus 3x plus 1. Now let's distribute. We get 5x squared minus 15x plus 5 plus 4. Gosh, I can't write a 4 today. Normally my 3s are really ugly, but today it's the 4. And then we get 5x minus 5x squared minus 15x plus 9. Do you see we got completely different answers? So be very mindful of which you are putting in as your input. That's why I like to rewrite it in this notation before I go further. If you rewrite it in that initial f of g of x function notation, it's usually pretty helpful. Anybody have any questions about 13? Okay, let's do 14. So, for 14, what is the input function? Can somebody just put F or G, type it out. What, for this one right here, what function is going to be the input? What function is going to be the input, F or G? You got it. G is our input. Exactly, Adam. So let's write it like that. Let's write it as f of g of x. And then take our g of x function and put it inside there. Now, it's not really going into it yet, but we have it now to look at. Okay? So it's going to go into our f function. So it's going to be 5 times that thing squared minus 1. So that's going to be the square root of 5x plus 5 squared. Now what's great about a square root and a square is they cancel each other out. And so this is just going to be 5 times 5x plus 5, which is 25x plus 25, take away 1, which is 25x plus 24. Now, think about the way that Adam typed in the input notation. Let's do the same thing for the second one here. So that's our g function, this time with f of x as the input. So take your f of x function and put it right there. Well, our f of x function is 5x squared, take away 1. So it's going to have to sit in the input location for g. So that's going to be the square root of 5 times our input plus 5. And our input is 5x squared minus 1. Now we might not be able to do much to this one because it's locked inside of a square root, but let's do as much as we can. So we get 25x squared minus 25x squared minus 5 plus 5. Oh, we can do a little bit. We get the square root of 25x squared, which is 5x. Not bad. Any questions about 14? Now, let's do 15. 15, we are composing functions, but with actual numerical values. And so it does, you can overthink these, okay? Now, let's rewrite it as an input. So let's take and write g of 9 is going to go into f. Well, now what does that mean? Well, that means, hey, I know I'm going to put 9 into g, and it's just, I can plug a 9 into g. So I'm going to ignore that the f function is really there, and I'm going to plug 9 into g. Well, 2 times 9 is 18. Take away 8 is 10. So I get a value of 10. Now just plug 10 into the f function. And we get 3 over 10 take away 4, which is 3 over 6, or 1/2. Don't make these harder than they are, okay? Sometimes you do, okay? So let's look at this function. We're going to take the g function, and we're going to plug in f of 6. So what does that tell you? Well, plug 6 into the f function first. Ignore that the g is even there. The 6 was closest to the f, plug it into f. Well, if I plug it into f, I get, what do I get? I get 3 over 6 take away 4, or 3/2. Now let's plug that into the g function. So I get 2 times 3/2 take away 8, which is 3 take away 8, or -5. Okay? So when you're inputting into a function, the one closest to the number goes first. You plug it into that function, get an answer, and then you plug that answer into the next function. You had 3 of them, you'd plug it into the next function, and you would just keep going down the line. Okay? Let's look at this one. So it says to find f of g of x and its domain. So we're going to take the g function. Well, let's write it over here. Just a second. We're going to take the g function, and we're going to input it into the f function. Now, the g function is what you start with. There are no restrictions on our g function. It's just a linear function. Nothing makes it mess up. Its domain is all real numbers, okay? But when we plug it into the f function, we do have to be careful because our f function is fractional, and so you do have to watch that a little bit. First, let's plug it in. So this is going to be 3 over the g function, 3x minus 2 plus 2. Let's simplify it. We get 3 over 3x. They're both divisible by 3, so that's 1 over x. So let's think about when we did restricted values from before. We know our restricted value here is 0. So our domain would be everything is going to work but 0. And that's the long way we write that, okay? Let's look at 17 and 18. Now, in 16 and some of the ones earlier, we were composing 2 functions. What 17 is saying is, if I wanted to split h of x up, what 2 functions could I have composed to start with this? And this is all you do. Look at what's inside. Inside there is 3x minus 7. Make that our g function. And make your your f function the outermost piece. Well, what's the outermost piece of that thing? A square root. Those are the 2 functions. Think about if I compose them. I would input this back where it belongs. Okay? So looking at 18, what is stuck inside of something? What would our inside function be? What do you think we could use for our g of x this time? You got it, yes. Our x plus 1 is stuck inside of that cube, so let's make that our input function. And then let's make our outer function the simplified version of what was originally there. So that's what they're talking about there, okay? And then I think this is the last one. I don't think I'm not going to do that. Let's just do the estimating function values from the graph, okay? So we have an f function in blue. We have a g function in red. Let's use it to figure out everything they want here. Okay. So in part A, they want to input 3. Now, this is just going to be the f function at 3. minus the g function at 3. Okay, so let's go over to our function. Let's look at an x value of 3. So you're just looking, well, what's the height of the f function? That's the blue height, is 1, 2, 3, 4. And then what's the height of our red function? That would be 3. And just subtract them. The answer is 1. Did that make sense to everybody so far? Okay, let's do the same thing for b. Okay, we're going to take the g function at -2, and we're going to divide it by the f function at -2. So let's go over here to -2. Let's go to the red function. That's going to go on top. That's down here. That is -4. And then our f function is the blue one up here, and that's +2. We're just going to divide them. -4 divided by 2. -2. We're done. Let's do C. The composition of g of f of 1. Now, I'm going to rewrite this as g of f of 1. Okay, so we're going to go over to an x value of 1, and we're going to only focus on the f function. What height is the blue function? The blue function is at a height of 2. So that is at a height of 2. Now we've got to go to the g function in red and find what's it doing at 2. So here's 2. What's it doing? It's at a height of 3. So we have to, in a composition, if we're using a graph, we have to jump from one function. So I used the blue function first, found the height when the blue function had an x of 1. It was 2. And then I went to the red function and used it to find what's its height when x is 2. Let's do this next one here. I don't know. Let's see. 1, 2. Oh, yes, it would be. I'm sorry. I wasn't using the blue function, or I used the blue function instead of the red function. Thank you, thank you, thank you. It would be 4 because we're up here. I'm sorry. Thank you so much for catching that. Goodness. Okay. It's a lot of notes. I understand that. We're almost done, thank goodness. Okay. Two more. So let's do f of g of -3. And I'm going to erase all these colors over here to help you a little bit, and help my brain, obviously, focus a little bit. So let's do f of g of -3. Okay, so we're going to look at the g function first. We're going to find an x value of -3, and the height at that point is 0. Now that I know what that is, now we're going to go to the f function. Did I use the blue function again? Okay, wait a second. I'm sorry. Let's try this again. Our red function is the g function. So if we go over to a -3, the value I want is the red one, which is 1, 2, -4. Okay. Now we go to the blue function, and we think what's happening at -4. 1, 2, 3, here's -4. The height I would be at, let's assume, is right there, -2. Sorry, I was getting them all messed up there, wasn't I? Now, E is kind of an interesting one, because in E, we are going to use the f function twice. So I'm only going to use the blue function, and I'm going to look at a value of -3. I am at a height of 0. And now I use the blue function again, and I'm at a height of 2. So hopefully I didn't confuse it too much, but so there is using the graph. So there's some function stuff. As you go through your mods that are coming up, please, if you have any questions, feel free to take a picture and show me. I am going to post these recordings so you can have them. And does anybody, before we leave, have any questions?